-1 eigenspaces of the delta action on this intersection homology. So we've got this geometric setting, and this delta is acting as an automorphism on that setting, and so these geometric invariants pick up an action of delta, and you have to compute this. And my thought around 2012 or so was that I'd just knock on Lustig's door and he'd tell me 10 words, and that'd be the end of it. I've written 2 papers with George, and George has written on his own 3 or 4 more. It's not trivial. I'll maybe try to spend the last, well, I'll give myself 5 minutes more, saying how some of the ideas in how Lustig found an extension of this Kazan-Lustig theory that computes these things.
Excuse me, David.
Yes.
So let me ask you a question. So,
Yes.
When I first saw this, I thought that this picture down here, that going from GK to GK delta, might just mean that you just need to just go back and redo the theory with a slightly bigger group. And I've learned over the years somehow that it really does come down to this delta action that you're talking about. But can you convince me that it's not a trivial thing going from K to delta? Well,
maybe because K already is not connected, so...
It's worse than that, yeah. I mean, one of the most, the case of complex groups regarded as real groups is already painful. And in that case, K is just diagonal copy of it's just a real it's just a complex reductive group of the most general kind. And
in that case, K delta is
the extension, that's this delta is just this swapping automorphism, and so it just is a direct product in that case, but nevertheless, the actions that show up here are tricky. The twisted Kazan-Lustig polynomials in the complex case are not a simple version. I mean, you might think that in that swapping case, these actions were always either just +1 or -1, but it's not the case.
Is it related to the difficulty of picking one of this extension?
Picking, sorry?
This difficulty, is it related to the difficulty of picking one of these extensions?
That's exactly right. That in the general case, that makes things hopeless here. I'm saying even in this swapping case, where I don't know. Yeah, I won't succeed in explaining why, but yeah, that's the point.
Well, I think it's fair to say that the difficulty in choosing these extensions is a major problem, but it's worse than that. It's not just that.
And can you choose the Whittaker model or something like that? I
Um,
think that's what Arthur did for GLM.
Well, but many of these representations don't have Whittaker models.
Yeah,
No,
but
but-
the standard representation always has one. So you can...
In a sense, we're doing that in order to we're sort of taking full advantage of that already in talking about these distinguished involutions and so on. I think I don't want to say any more today. That what I was going to do for the next 20 minutes, if it ends up being a reasonable thing to talk about, is how this extension stuff works for vial groups. That's really interesting, and that's, I mean, of course, the Kazan-Lustig computation of these things is entirely run inside the vial group. And Lustig's extension has to do with extending the vial group by adding this outer automorphism. And it's, you know, it's sort of the finite group world again, so it's in some ways simpler, but nothing that Lustig thinks about as simple. It's beautiful, but anyway, that would be another possible topic. Here I'll just stop and say thank you. Susanna.
Another possible thing might be to give an example that illustrates what's going on.
Yeah, so let me address that. That's me.
He's the example man.
So I'm the examples guy because that's all I know how to think about anyway. And, so after the break, we'll reconvene at 10:30. I'll do some computers, well, a mix of talking and computer examples of this. I may not take that long, and if you have another, if there's 20 minutes at the end and you can do this file group thing, we might do it. And then we're at 1:30, Paul Mezzo is going to talk about this same stuff from his point of view.